In Chapter 6, I'd like to take a look at addition of common fractions. Well, what is a fraction anyway? A fraction is a part or a portion of a whole. So, for example, each inch can be divided into 8 equal parts. Those parts are called eighths. So I've shown a section of a measuring tape here, or ruler, with the 0 marker right there and the 1. So this whole distance is 1 inch. And that inch has been divided into 8 equal parts, which are shown here, here, and so on, right? And each of those are eighths. As another example of eighths, we could also divide a circle into 8 equal parts. And so if you see here, I have a division there. And so we've got one of them, 2. Actually, we'll count them differently. 1, 2, 3, 4, 5, 6, 7, and 8 equal parts, okay? That's why that's underlined. What is shown with this diagram, the shaded area, are 5 of those. So that's the numerator, the number of shaded areas in our whole. And the denominator represents the total number of equal sections in the whole. What is left over and not shaded, 1, 2, 3, are 3/8. And it should be noted that we can add those eighths, 3/8 plus 5/8, and we'll see we keep it as eighths, that denominator does not change. Add the numerator, 3 plus 5, and we get 8. So 8/8 equals 1 whole. A little bit of terminology to go with fractions. A proper fraction is when the numerator is less than the denominator. And when the numerator is less than the denominator, let's look at a few more examples. Something like 2/3 or 4/9. Each of these represent a value that is less than 1. On the contrary to that, an improper fraction is when the numerator is greater than the denominator. For example, 10/3 or 5/2. Each of these represent a value that is greater than 1. Now, improper fractions can also be written as mixed fractions, where you have a whole number and a proper fraction combined. Because since something like 10/3 represents a value greater than 1, so then it would have a whole number that is greater, 1 or greater, and it will have a leftover part, the portion or that is represented by the proper fraction. So in order to convert that, I would ask myself, how many times does 3 go into 10? So 3 goes into 10, 3 whole times, right? So 3 times 3 is 9, and there is 1 left over from 9 to 10, so there is 1/3 left over. See if you can do the same thing with 5/2. Pause the video and convert it to a mixed fraction. So we ask yourself, how many times does 2 go into 5? Well, 2 goes into 5 twice. 2 times 2 is 4. And if I subtract 4 from 5, there is 1 left over, and those are in halves. Notice that each time I kept the same denominator. That did not change. So we looked at going in this direction. If you want to go back, you would do 3 times 3 plus 1 to get the new numerator. 3 times 3 is 9. Add 1, we get 10. Keep the same denominator, 10/3. With the other one, 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. 5 halves. And these represent a value greater than 1 as well. It's just another way to express an improper fraction. In this chapter, we focus on addition of fractions. For addition of fractions, you must have the same denominator. So in other words, you want to think about it as having the same size pieces. And if the pieces are the same size, then they can be added. If they don't have the same denominator, you must find a common one. It is best to find the lowest common denominator, although it still works to find any common denominator. Finding the lowest common denominator means you're less likely to have to reduce the fraction. Adding fractions with common denominators is very simple. We would keep the same denominator. In this case, it's 8ths because we're adding 3/8 plus 2/8. Keep the same denominator, add the numerator. I'll ask you to pause the video and find the sum of 1/4 plus 2/4. And so, since the common denominator is 4, we will keep the common denominator of 4. I will add 1 plus 2, and I get 3/4. So adding fractions with common denominators is pretty easy. It becomes a little more tricky when you have to find the lowest common denominator. So let's talk about a method for finding the lowest common denominator. And there's one new word that will maybe come into play here. Maybe you've heard before, but it could be a new word, a prime number. A prime number is a number that is only divisible by itself and 1. So let's think about a few. Well, 2 is a prime number. 2 is only divisible by 2 and by 1. 3 is also a prime number. 3 is only divisible by 3 and by 1. What about 4? Well, 4 is divisible by 4 and by 2 and by 1. So 4 is not a prime because it's divisible by more than just itself and 1. 5 is a prime number. It's only divisible by 5 and 1. 6 is not a prime number because 6 is divisible by 6 and 3 and 2 and 1. 7 is a prime number. It's only divisible by 7 and 1, and so on. So 11, 13, 17, 19, these are all prime. I could keep going, and I won't do that for you. So when you factor a number, that is, find the factors that make up a number when they're multiplied together, factor each number or each denominator into its prime factors. 6 is divisible by 2 and 3, and 2 and 3 are both prime. 2 appears once, 3 appears once. And then we will factor 9 into its prime factors. 9 is also the same as 3 times 3. 3 appears twice. The lowest common denominator, the LCD, is the product of each of these primes, the greatest number of times they appear in either of the two factors. So 2 appears once, 2 does not appear as a factor of 9. So we will use one of those 2's, or that 2 there, once. 3 appears once in the first one, but twice in the second. That is the greatest number twice. So we will have to have 2 of them there. And when we multiply those together, we get the lowest common denominator of 6 and 9. Next, we should look at how we use the lowest common denominator. If I need to add 1/6 plus 2/9, and that means I do not have common denominators, so I need to convert each of these to a fraction over the lowest common denominator that I have already found. I found the lowest common denominator to be 18, so I'm going to convert these to 18s. And so we have to think about, well, I need to use a ratio. If I need to convert 6 up to 18, what happened there? That was multiplied by 3. If we multiply the denominator by 3, we should also multiply the numerator by 3. 1 times 3 is 3. So this tells us that 1/6 is the same as 3/18. Now we move over to the other fraction. To convert 9 up to 18, what did we have to do? Well, that's times 2. So since I multiply 9 by 2, I should also do the same to the numerator. 2 times 2 is 4. Now I have 2 fractions with common denominators in 18ths, and I can now multiply the numerators. 3 plus 4 equals 7, and so the answer is 7/18. Another way to find this value, 3. Well, 6 is 2 times 3, right? Right there, 2 times 3. The other missing value is the 3, so that's what I use there. Let me erase that, and we'll go look at the 9. 9, right here, is 3 times 3. The other missing value is 2, so that's what I use there. Okay? So keep in mind, you must have common denominators to add fractions, and so you have to find it if you don't have it. Here is one for you to try. Pause the video and try to find the sum of 3/4 plus 3/5. 4 is equal to 2 times 2. Those are its prime factors. 5 is equal to 5 times 1. And so the lowest common denominator is equal to the greatest number of each of the factors. So 2 appears twice here and none in the second one. So we must use 2 times 2. 5 appears once here but none above, so we need 1 5. And I could say the 1, but I don't need to multiply by 1. So this product is the lowest common denominator, which is equal to 20. So I should be adding 20ths. Now I need equivalent fractions. So 4, which is 2 times 2, 2 times 2, needs to be multiplied by 5 to get to 20, right? So I should multiply by my 3 by 5. So 3 times 5, 15. And you can probably picture that. 3/4 is the same as 15 20ths. Now 5 is right here. We should multiply it by 2 times 2. So 5 should be multiplied by 4, so 3 needs to be multiplied by 4. And now we can add 15 plus 12, put it over 20, and we get 27 20ths. Just as a recap, convert that to a mixed number also. How many times does 20 go into 27? Well, we can only get 1. Using up 20 of these 27, we are left with 7 left over in 20ths. Now let's look at a tape measure. The wood trades mostly work in halves, quarters, eighths, and sixteenths. So we should focus on those. So here is my inch, all right? And I could put any whole number at the beginning of it. So we can start with 0 here. And this will be where the 1 inch marker is. All right. Halfway between 0 and 1 is 1/2. Notice on a tape measure, and you can look at your own as well, that it is the longest mark. Okay, so it goes down to there. Okay, it's the longest mark. If I divide each of those halves in half, then I end up at 1/4. Right? So 1/4 is the second longest notch down. And if you notice, we have 1/4 there. That's terrible. 1. That's 1/4. That's 1/4. Oh, let me fix that. And that's 1/4. So 1/4, the next one would be 2/4, which is equivalent to 1/2. This will be 3/4, and 4/4 is 1 whole. Now, if I break each of those quarters in half, I will have eighths, right? So this is an eighth to here. The next eighth, this is 2/8. Well, 2/8 is equivalent to 1/4. This is 3/8. This is 4/8, which is equivalent to 1/2. This is 5/8. 6/8, which is equivalent to 3/4. And 7/8, and a whole is 8/8. We will go one further, and we're going to divide each of the eighths in half and turn them into sixteenths. This is 1/16. This is 2/16, equivalent to 1/8. This is 3/16, and this is 4/16, which is equivalent to 1/4, which is equivalent to 2/8. 5/16, 6/16, 7/16, and 8/16, which is 1/2, 2/4, 4/8, 9/16, 10/16, 11/16, 12/16, which is 3/4, which is 6/8, 13/16, 14/16, which is equivalent to 7/8, 15/16, and 16/16, which is 1 whole. Now I have done up to 16ths. If each of these is divided in half again, we would have 30 seconds. But let's just focus up to 16ths right now. And it's really important to understand the equivalent fractions in this case. Here's a practice for you, adding mixed numbers. To add mixed numbers, you add the whole numbers and then you add the fractions. Or you convert to improper fractions, find the lowest common denominator, and change the fractions with common denominators to fractions with common denominators. Then add the numerators and keep the common denominator. In this case, I'll look at both ways here, and then I'll let you practice with the next one. So let's do the first method. Add the whole numbers, then add the fractions. We have 6 plus 2 plus 1/4 plus 2/4. I've already got common denominators, so I don't need to worry about that too much. Let's add the whole numbers. 6 plus 2 is 8, and for quarters, 1 plus 2 is 3/4. Now, if this 3 was to go greater than 4, that would increase my whole number by 1. Or whatever number of times 4 is multiplied in there. Let's look at the other method. Convert to improper fractions. So let's convert to improper fractions. And first, let's write down the question again. There's 6 1/4 plus 2 2/4. So to convert to improper fractions, 6 times 4 plus 1. 6 times 4 is 24, plus 1 is 25/4. Plus 4 times 2 plus 2. 4 times 2 is 8, plus 2 is 10/4. Now I can add my quarters. 25 plus 10, 35. So 8 3/4 is equal to 35/4. Because 4 goes into 35 8 times. 8 times 4 is 32. And 35 minus 32 is 3 left over. Now I have one for you to try. And this involves finding a common denominator and then adding the mixed numbers. Pause the video and give this a try. So 2 is equal to 2 times 1. That denominator. 8 is equal to 2 times 2 times 2. And the lowest common denominator is equal to the greatest number that each prime factor occurs. 2 appears once here, but 3 times here. So the lowest common denominator is 2 times 2 times 2, which is 8. And we might already see that by seeing that 8 is actually a multiple of 2, so we can quite easily convert halves to eighths. So let's do that. 10, and I need to put this into eighths. How many eighths is equivalent to 1/2? So 2 should be multiplied by 2 times 2, which is 4. So I must multiply by 1 by 4. And I want to add to that 3 5/8. That's already an eighths, so it can be left that way. So we will add the whole numbers, 10 plus 3, and then we will add the numerators of the eighths. So 4 plus 5 is 9/8. Well, generally we wouldn't leave it like this because 9/8 is actually 1 1/8. So if I steal from here, I'm going to steal 8. All right, steal 8, which leaves 1 over. If I steal 8/8, that increases this to 14, and we're left with 1/8. We want to add to that. Oh no, sorry, that's been added already. So 14 1/8. Let's do it the other method by first converting to improper fractions. We're going to have to find the lowest common denominator at some point, so you may go and find it first, and then you might convert to improper, where we have 10 and 4/8 plus 3 and 5/8. And remember, the process was 8 times 10 plus 4, right? So 8 times 10 is 80, plus 4 is 84/8, plus 8 times 3 plus 5. 8 times 3 is 24, plus 5 is 29/8. And we will find, when we add the numerators, that it is 113/8. Well, that's equivalent to 14 1/8, because we would ask ourselves, how many times does 8 go into 113? And if you're not sure, you can grab a calculator and do 113 divided by 8. And you will see that it's 14.125. That means that 14 is the whole number. So I did 113 divided by 8 on the calculator, and I get 14.125. 14 is the whole number. Oops. And I want to know what's left over. So 14 times 8 equals 112. When that is subtracted from 113, we get 1. Okay, so there's lots of practice in the book. I suggest that if this is unclear to you, or you feel like you need a refresher on it, that you should practice questions from the textbook. Thanks for watching.